the same. We talk about translation, initiation, elongation, and termination. For translation, initiation, elongation is more complicated than termination. Termination is relatively simple and relatively easy because we have a stop code. Okay, so we want to talk about that. Initiation. So first of all, at the beginning, we see, let's draw like this. Just like this. There is a 30s subunits. This 30s subunits on the side is attached by initial factor 3. What's a function it is? If you're not doing the translation, we'll just keep you rest. So we separate with 50 S subunits. 50 S subunits is on the top right here. They are not combined, just release. And once the body said, I'm going to start to do the translation, something going to come on, which is called initial factor 1. They will knock this off. So, initial factor 3 is gone. In the later on, what happened is right here. This is still 30s. This initial factor 1 is attached to the other side of the 30s subunits. Make sure it is ready to have the 50s subunits going. Okay, then you have an initial factor 1, initial factor 3. What is the initial factor 2 going to do? Initial factor 2 is like a tray or a trailer or like a car. It's not only is a trailer, they only carry some money. That is GTP. And then they carry what? They carry a TRNA. This TRNA is the first one your MET comes. For example, that's TRNA. Okay, once they go in, what are they going to do? You have to pay the money. So GTP will become GDP. And then IF2 will release. And then what's going on? This is 30s. This is attached to initial 8 factor 1. And this right in the middle. Okay, it's MET. It's TRNA coming. And then get ready. That big 50S subunits is covered. Then become a whole completed ribosome. Now, how they initiate, we just talked. You need to see there's an SD sequence. There's a shy diagonal sequences there. Okay? So that's why it comes out like this, mRNA. Then they start to do. Okay, now, what's going to happen next one? The first one, initiation. The second one will be elongation. Elongation, I don't have a picture here, but we can talk. The second one is elongation. When we talk about elongation, 30 subunits is already there. 50 subunits is there. We need to talk about those 3 boxes. You will see 3 boxes in the middle and in the intersection of 30 subunits and the 50 subunits. The position is called EPA. Very interesting, not the Environmental Protection Agency. Its acronym is the same as EPA. What does E means? exit site. Which means later on, this tRNA will release. What is P? Peptidyl site. The peptidyl site happened is translocation. And let the peptide become longer and longer. So they need an enzyme, which is peptidyl transferase. And how about the A? Amino acyl binding site. Or you can say an amino acid acceptor site. So the key thing is that how they move then. Okay, we're going to have to draw right here. Let's say I have a tRNA right here. It is MET. At the beginning, it is in the P position. Then you're going to ask me when the first one going to comes. This is the same as eggs and the birds. Which one comes first? Nobody knows. I asked the same question when I was a student. The teacher says it's the same as an egg and the birds. Which one comes first? So we assuming start from here. The MET is already in the middle. Okay, that's all the textbook started. I have the same question where this first sentence come from. Then we don't know probably. Regarding the translation and transcription, there's still lots of things doing in the research right now. So that's why it comes out, especially the polymerase, all those things. That's why there's news comes out to win the Nobel Prize all the time with those things. Because we don't know. Okay, so we start from MET writing the P. Okay, the second one. Then you have tRNA going here. It is AA1, amino acid 1. Then what's going to happen in the second one? How they move? This direction. Okay? How they move? So we're going to have to draw a little bit small right here. How they move? EPA. It is very interesting. Is this guy goes here. So what's going to happen? Is this blue one is go to the E position. And this red tRNA is go here. We'll have AA and MET is always at the beginning. And then you have a new one coming. Okay? I had a new one coming. They're going to carry on AA2. So what's the next step? This guy is going to release. This tRNA is going to release, and then to find another amino acid to carry on. And this goes here. We draw 30S subunits, 50S subunits. Then you have position E, P, A, and what's going to happen is actually this one moves here, empty. And then this guy goes in the P, which has become AA1, which has become AA2, AA1, and at the beginning is MET. Then you have another one coming, which is might be AA3, and they go this direction. But when they synthesize, it is always 5' to 3'. This is a process, is translocation inside of 50S subunits. And when they do this connection, they need transpeptidase. And where it is underneath 23S rRNA. And where is this one? Located inside 50S subunits. Okay, now, next one, we want to explain to you what really this happened. This is what we just draw here. Okay, it's just an elongation. What happened? we move it. It's okay. Then now we're going to tell you what is really happens. Okay, on the P side, this is A side. What really going to happen? Okay, it all started. I have this guy right here. It's a base. It's a H. It is H. OH. It is H. Okay, I have O. I have a C. O goes here. We have a C. Let's say I have MET. Let's say. Okay, I have a H. NH2. Okay, then I go here is CO, CH. This is, let's say, arginine, let's say, okay, NH2. Not NH2. Go here. Okay, now you go here, this will be H, CH, this is O, phosphates, phosphate. Now what they connected? Connected here is this guy right here. We just talked about this tRNA right here. This is 5 prime, this is 3 prime, they connected. Okay, let's say this line is in the P side. Now I have something in the A side here. So here we have to draw more clearly, let you know. This amino acids, is that right? This is also amino acids. Okay, in the A side something is coming. Let's say you have A coming. Okay, you have H, OH, H, O, then you have C, O, so you go have C, you have let's say alanine coming, and then you go have H, in NH2, then you go here, this is CH2, O, that's phosphate, okay, and with the tRNA is right there. We just draw briefly. So what are we going to do? This guy will be attached to it, right there. Sorry, this should be ARG. MET is always the first. So I usually draw is R1. It should be the R. This should be the RN, N plus 1, and this should be the RN. And let's say this is RN plus 2. This guy goes there, is attacking here. So what happened? This go Rn plus 1, H, NH, then go here, Rn, Rn, and then go here, H, and NH2, then like this. And at the beginning one, it is always MET. Now you may be confusing. You go this way, how come you go that way? The textbook cannot turn it over. So you need to flip upside down. When you see upside down, you will understand how they connected. And these connected is simple. This is peptide bonds, is that right? In your biochemistry, that's a peptide bonds. That's what it is, how they connected. This is what we talk about from a structure standpoint, and this one is just we do the translocation. Okay? Now the last one, termination. Termination is easy, because we already see you have a stop code, UAA, UGA, and UAG, then this will be released. The amino acid bonding will be, the sequence will be released. So it's pretty straightforward how they release, how they stopped. Now, by the way, when this translocation happens, they need a GTP and TU. They need a hydrolyze to become GDP. That's the energy they're using. Okay, so that is a process. Let's see the binding site. That's all the binding, that's all the stopped. It's anti-codon, and this is a process how we talk about. This is a process how we talk about instant termination. Okay. I think we have 10 minutes. Let's talk about the amino acids if you want. I don't know, I have already talked about an hour, so we'll see whether I can remember all of them, but we'll see if we can learn it, okay? So let's do the amino acid. Just give you a brief review. If I forgot, then forgot, we can go from there. So, translation. At the end of the day, we need amino acids. There is a 20 nature amino acid. NH2, CH, COOH, and the side chain is R. And the biochemistry book has been categorized them into different groups. The first group is non-polar and non-charged. Of course, it's no charge. And because most of them are the same, the major structure are the same, so in the exam, I only require you to write the all side chain. Okay, so let's go ahead. H, glycine. Something I will mention if we talk in the lab. CH3, alanine. Then we have CH2, CH3. What is that? Valine. Then we have CH2, CH2, CH3. This is leucine. Then we have CH, CH3. Sorry, that should be CH3. So that should be CH2CH. Sorry, leucine is CH2CH, CH3, CH3, that is leucine. Okay, then you move down one thing, CH3, CH2, and CH3. This is ILE, which is isoleucine. Isoleucine, we say, it's like an isomer. It's the same morphology. The only difference is that the same molecular weight, the morphology is different. Okay, then the next one, we have to draw the whole thing. Because this one is a circle. So we have to draw the whole thing. It's CH2, CH2, and go CH2, and then connected, that's pyrroline. I'm not done yet. We still have several. This one we talk about in the lab. This is phenylalanine. Phenylalanine. Phenylalanine deaminase. Remember using ferric chloride showing you dark green color is deaminase. Left is a phenylpyruvate. That's a phenylalanine. Then the next one is CH2, SH. That is cysteine. But this guy is a question mark. Most of the textbook put it as a polar non-charge, but some textbook put non-polar charge. And the last one is methionine. Okay, we just mentioned it. CH3, S, CH2, CH2. That's methionine. And the methionine you definitely need to know because it's the first amino acid usually do in the translation, and we call it the formula methionine is for bacteria. So this is pretty much done with the first group, is non-polar, non-charge. Then the second group, we call it a polar and no charge. So polar, no charge, the first one. CH2OH. This is serine. Then we go CH2, OH, let me see, CH2, sorry, CH3, OH, serine. Then we go CH, NH2, this is asparagine. Then we go CH2, CH2, then we go C, this is glutamine. Then the last one is CH2, this is tyrosine. This is the group which is polar non-charged. Then the group is polar going to charged, which means it is hydrophilic. Is that right? Now, very simple right here. When you have the asparagine, right here, so it's very simple. You could come out with aspartic acid. This is negative charged. You have a glutamine. It's very simple. You can come out with glutamic acids. Now remember, sodium glutamine is using for the taste. Is that right? When you make the foods, you do some of the taste. You do the glutamine. Sorry, that's CH2. Okay, the next and last three one. What are they? Histidine. Histidine is usually the most difficult one to draw. I didn't always draw very well because it's a little bit tricky. So NH, go here, go here. That's histidine. Histidine we have to take a look because I didn't draw that one very well. Next one is lysine. CH2, 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 very long. Then NH2. That is lysine. Now lysine, this guy we call it an epsilon amino acid. Is that right? Because it's a long chain. And the lysine is very prolific in milk powder. So that's why the milk powder left in the room temperature, then reacted with glucose, lactose in the milk powder will become what? Will become a brownish yellow color. It's called a Maillard reaction. That's a lysine. The last one is arginine. Arginine is CH2, 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 then go NH, then go C, NH2, then you have a double bonds right here, and it's positively charged. And I miss one here, which is tryptophan. Tryptophan is right here. We mentioned about that. Is that tryptophan? Tryptophan is non-polar, non-charged, and this is indole. Is that right? So that's basically the amino acids, 20 amino acids, a side chain. I have missed a little bit, but majority of them I get. So there's one more thing. There's a joke here. Histidine, lysine, and arginine. How to remember it? It's just a joke, not for insulting, okay? His or her letters are basic. Do you know the joke about that? Which means people, the young kids in the university that not study very well, they have a long boots. We call it a leggers. And then they just hang around in the campus to show off their very fashion. Is that right? So then we say, his or her leggers are basic. Histidine, lysine, arginine are basic amino acid. It's positively charged. Is that right? So that's a joke for you to remember all these. Okay, so that's all we have. I'm going to go over this one more time in the lab next Tuesday, then we get to know again more familiar. Okay?